Okay, our second FRQ for the week is number 2. It says, when a certain grocery store opens, it has 50 pounds of bananas on a display table. Customers remove bananas from the display table at a rate modeled by, so that is F of T right here. So that's our rate of change of the bananas being removed from the table, where F of T is measured in pounds per hour, and T is the number of hours after the store opened. After the store has been open for 3 hours, store employees add bananas to the display table at a rate modeled by G of T, where G of T is measured in pounds per hour and T is the number of hours after the store opened. So part A says how many pounds of bananas are removed from the display table during the first 2 hours the store is open. So we're going to be looking at F of T. F of T is the rate at which the bananas are being removed. So that's our derivative of however many bananas are there. So what we want to do is find the antiderivative of F of T. So think about this. Again, think about your units. This is in hours. This is in pounds per hour. Okay? We want to know how many pounds. Notice what happens if you multiply these two units, you're left with pounds. So if we have this function F of T, and if you did look at the graph, look something like this, okay? If we want to figure out how many pounds have been removed for the first 2 hours, what do we want to do? Calculate the integral from 0 to 2, and that'll give us the total number, or total pounds of bananas. So for part A, we are going to evaluate 0 to 2 F of T dt, and that will equal 20.051 pounds have been removed. Okay. Part B, find F prime of 7. Using correct units, explain the meaning of F prime of 7 in the context of the problem. So F of T is given by that. F prime of T, we could go through and find our derivative. We would have to use product rule here, and within both of those use the chain rule, but this is a calculator question. So if you have this graphed in your y equals, you can calculate F prime of 7 by just hitting second calculate number 6 is our dy dx and type in 7, and you end up getting negative 8.11954. Okay, so obviously that's not going to be our final answer there. One, we need it to 3 decimal places. If we truncate it, we are right there at negative 8.119. If we round it, we're at negative 8. That 5 is going to move the 9 up, and it'll end up being 1 or 0.120. Okay, so you have to remember that our function f is the rate of change of the bananas, and now the derivative of that is the rate of change of our rate of change. Okay, so let's think about the meaning of that. So it says explain the meaning of f prime of 7. So what that's telling us is at time equals 7 hours, the rate at which bananas are being removed is decreasing by 8.120 pounds per hour squared. Okay, so if you think about it, when we talked about like the position function, the position function, the derivative of that was your velocity, and the derivative of that was your acceleration. So what we just did here by finding f prime of 7, we found the second derivative of the function that represents the number of pounds of bananas on the display table, okay? Because f of t is that function's derivative. F prime of that is its second derivative. So at time equals 7 hours, the rate at which bananas are being removed is decreasing, okay? So it is slowing down there. All right, part C. Is the number of pounds of bananas on the display table increasing or decreasing at time equals 5? Give a reason for your answer. So what we want to look at here is the function values at 5. So we're going to evaluate f of 5 as well as g of 5. Okay, we want to see if more are being removed or more are being put back on the table. So when we plug in f of 5, we get 13.795938. When we plug in g of 5, so when we evaluate that, we get 11.532835. Okay? So since f of 5 is greater than g of 5, and f of 5 is representing the rate at which the bananas are being removed, and g of 5 is representing the rate at which bananas are being put back. So since the rate at which they're being removed is higher, that means that the number of pounds of bananas on the display table is decreasing. Okay, and then the last part, how many pounds of bananas are on the display table at time equals 8 hours since the store has opened. Okay, so let's think about this. At time equals 0, so right when it opens, there are 50 pounds, right? Now what we're going to do is in that 8 hours, we're going to subtract the total number of bananas removed, and that total number comes from the integral of the rate of change of which the bananas are being removed. And then we're going to add the total number of bananas that have been added using our function g. But notice our function g doesn't start till 3 hours after it's opened. Okay, so for the first 3 hours, just bananas are being removed. And then from hour 3 to hour 8, you have bananas still being removed, but also you have some being added back to the table. So if we do the integral for f of t, that's going to give us the total number of pounds of bananas removed in the first 8 hours. If we do the integral here, that's going to be the total number of bananas added back to the table from hour 3 to hour 8. So all you're going to do is you are going to have to use your calculator, okay? So you get 85.61661. This integral is 58.964056. And notice I am not rounding yet. You got to wait to the end. So once you add this all and round or truncate to 3 decimal places, you will, or the store will have 23.347 pounds of bananas on the display table. Okay, so hopefully if you missed anything on that, listening to this kind of cleared up some of your confusion, maybe from looking at the answer key and grading it. So, all right.